Okay, the deal was you do exercise 3, and I would do a video for exercise 4. So when a ball bounces up and down, the maximum height it reaches decreases with each bounce in a predictable way. Suppose, for a particular type of squash ball dropped on a squash court, the maximum height, h of x, after x number of bounces can be represented by 65 times 1/3 to the x power. Determine the height after the first bounce. So we identified that our A is 65. So we're saying we're dropping that ball from a height of 65. B is 1/3. So remember, in an exponential function, we care about what we keep. So our new height is going to be 1/3 of the old height every time. Now, if there's on the first bounce, in this case, x is going to be equal to 1. So we take our function, h of x equals 65 times 1/3 x. And what we want to do is everywhere that we see an x, we want to replace it with 1. So we plug in our 1, and when we do that, we're really saying 65 times 1/3. And 65 times 1 is 65. So we get 65/3. But when we simplify that, what we're really doing, because 65/3 to a lot of people doesn't have any meaning. But when we multiply 65 times our 1/3 to get 65/3, we say, how many times does 3 go into 65? We have 21 with a remainder of 2. So that simplifies to 21 2/3. Now we want to do the same operation, replacing our x with 3. So we take our function, a and b are the same, it's the same function, we're just changing our input of x. Now x equals 3, so replace x with 3 everywhere throughout the function. And we get that the h of 3 is 65 times 1/27, or the h of 3 is actually 65/27. Now, 27 goes into 65 twice, and we get 54. So the h of 3 equals 2. So for question B, it says, how much greater is the height of the first bounce than the third bounce? So what we're really doing, we know that this one is a lot bigger than this one. So I go back to the fraction and I say 65/3 divided by 65/27. And what happens is actually kind of interesting. When we put that in the calculator, even though our inputs are pretty ugly, our output is actually just 9. And that's how we do B. Now, for C, we want to graph the points 0, 1, 2, 3, 4, 5 on the graph below. So my first point, when I put in 0, is my y-intercept. And in this case, it's 65 times anything raised to the 0 power. I still have this 65 in front. So we have 0 and 65. Now, then when x was 1, that's where we got that point that was 21 2/3. So I'm going to go to 20 And to get 21 and 2/3, I just have to go just a little bit above 20 to 21 and 2/3. Now, we need to do 2, and we haven't calculated 2 yet. So when I plug in 2 to my function, I get 65 times 1/3 squared, which is 1 over 9. So I really get 65 divided by 9. Now, 65 divide 9 doesn't give me a nice number, but it does give me something I can work with, because 9 times 7 is 63. So I know that my answer is something just over 63. So I put my 7, and 65 minus 63 is 2, so that leaves 2 over 9. Now, in all honesty, I'm lucky to be able to find a good plot for the 7, so that 2 over 9 is not going to change my life much at all, because 7 is somewhere between 5 and 10, so it's a little closer to 5. So there's where our second point is. Now, 3 regraphed, and that answer was right around 2. So now let's do 4. When I calculate 4, 1/3 to the 4th is really 1 over 81. So this is 65 over 81. And what I can tell you about 65 over 81 is that's actually a point, since the numerator is smaller than the denominator, less than 1. So this is really, really close to the x-axis. Now, the last one we need to do is 5. So when I get to 5, we put in 5 for, and remember, when we did 4 over here, we got a fraction where the numerator was smaller than the denominator. Now the numerator is a lot smaller than the denominator. So 65 over 243. What that means is this is a positive number. So I'm still above the x-axis, but I'm so close to it that I'm almost touching it. And that's where the x-axis is an asymptote. So as this denominator gets bigger and bigger and bigger, it's going to shrink. But that means that I'm still getting closer and closer to the x-axis, but I still have a positive value. So I never cross that x. And just a little note, if you're borrowing these numbers, make sure you waited until the end, because I had to go back and edit a few things. We are talking about the h of 5, which is 65 times 1 over 3 to the 5th power. And our result was 65 over 243. And that's what our exponential function looks like for the graph of how this ball is bouncing.